Hey everyone, it's Miss Linder, and we're going to be working on taking the notes for lesson 20. All right, so let's go ahead and start. We're going to be writing function rules for each table. You're going to show your guesses or thinking, and actually after this lesson you should be able to show your thinking. All right, so what we're going to do is we're trying to figure out the rule that applies for the function. Okay, so let's look at number 1. You're trying to figure out how did they go from having x to having 3. So what rule happened to go from 0 to 3? Now remember, there are 4 operations. You can do addition, you could do subtraction, you can do multiplication, and division. And sometimes we know that we have 2-step equations. So sometimes you're doing 2 of these things at the same time. All right, so let's start with number 1. One of the ways that I like to teach this is to put off to the side, how did they do this? So how did we go from 0 to 3? Well, that means we would have added 3. All right, so let's see, what do we do on the next one? It's a terrible addition of 3, sorry. We added 3. So how did we go from 2 to 5? Well, we also added 3. How did we go from 4 to 7? Well, we added 3. So if you end up seeing 3 of them give you a pattern, then you have found the rule. So what we're going to do, we're going to say the function of x for this table is x plus 3, because this function can change. We could say, what was the answer when x was 99? So we would plug in 99, add 3, and that would be our answer. All right, so let's look at number 2. Number 2, we're going to say, how do we go from 0 to 0? Well, we would have either added 0 or multiplied by 0. All right, so let's see number 2. That doesn't help us very much. So let's see, how do we go from 1 to 3? Well, we could add 2, or we could have multiplied by 3. So let's see, how do we go from 3 to 9? Well, we would have added 6, or multiplied by 3. I've got 2 alike. So let's see, how did we go from 5 to 15? That would have been timesing but 3. There's the pattern. So let's see if it works for this first one. So if I took 0 and multiplied it by 3, does it give me 0? Yes. So we found the rule. So let's write it. The function of x. Now we're doing multiplication. So we need to make sure we write 3x. So whenever we take the x, because that changes, and we multiply it by 3, we're going to get the function of that x. We're going to get the answer. All right, let's look at number 3. So how did we go from 5 to 0? Well, we could have subtracted 5 or multiplied by 0. How do we go from 10 to 5? Well, we subtract 5. That looks like it might be a pattern. Let's look. 15 to 10. Looky there. Subtract 5. So let's write the rule. The function of x is x subtract 5. All right, I want you to try number 4 on your own. Number 4 on your own. All right, so let's see. How do we go from 3 to 9? Well, you could add 6, or you could multiply by 3. How do we go from 4 to 16? Well, you could add 12. or multiply by 4. I don't see a pattern within those. So gee, let me think. I'm thinking though, if we were to do something, I'm noticing I see powers. I'm seeing an exponent power. Let's try if 3 was squared. 3 times 3 would be 9. If 4 was squared, 4 times 4 would give me 16. If 5 was squared, 5 times 5 would give me 25. So I found the pattern. So that's one of the ones that exponents helps out. So the function of x would be x squared. All right, let's move on to number 5. All right, I'm going to go ahead and ask that you try it out, try and see if you can figure out number 5, and then we'll come back and work together. So in other words, when I look at your notes, I should see your guessing and your thinking. So I should see something that you're doing to think about number 5. And then I should also see your notes. All right, so here we have plus 15 or times 16. Here we have plus 21 or times something, something, something. Here we have plus 27 and something, something, something. All right, so we have a little crazy looking thing here. I do notice that I kind of have a pattern with my first guys here. So you can work with that pattern, or we can go ahead and test out some theories. So if we were to multiply, I'm going to not use the 1, I'm going to use the 2. So if I was going to multiply and try and get close to 23, I might multiply by 10 and add the 3. So let's see if I multiplied this by 10 and add a 3. No, that didn't work. So that wouldn't be what I need. So let's try 2 times 9. Then I would see what I could add. So that's 18. 18 to 23 would be adding 5. So let's see if that works for the next one. 2 times, or 3 times 9 plus the 5. So that's 27 plus 5. Not working. All right, so let's try some other options. That doesn't erase. All right, now I do know that this one's super hard. Okay, this one is super difficult. So if you can't find it going horizontal, we're going to look at vertical. So here we go from 16 to 23. And that is by adding 7. How did we go from 23 to 30? Well, we added 7. So how did we go from 30 to 37? We'd add 7. All right. So we're going to go ahead and take that 7 and we're going to multiply it by our x because that pattern is vertical. So we're going to use the multiplication. So 7 times 1, and we need to get it to 16. So 7 times 1 would give you 7, and then to get to the 16, you would add 9. So let's see, 7 times the 2 plus something to get to the 23. So 14 plus something equals 23. Well, that becomes 9. So you found what you need to do by using the vertical pattern, which we multiplied, and then we had to figure out how did we go from that multiplication to the answer. So the rule for this one would be the function of x is 7x plus 9. Okay? All right, let's look at number 6. How'd we go from 1 to 5? Well, we added 4. How'd we go from 2 to 6? Oh my, looky there, add 4. And you thought it was going to be difficult. And then we add 4. All right, so our function of x is the x plus 4. All right, I want you to go ahead and try number 7, 8, and 9, which is on the next page. 7, 8, and 9 on your own. Don't forget, I should see some thinking and then my notes. All right, for 7, 8, and 9, you'll notice that we have now x and y. We want to find the rule, and we're still talking about the function. So how did this stuff take place? How did we go from x to y? So we're still looking to that function rule. All right, so for number 7, you found that it was squared. So you should have had the function of x is equal to x squared. All right, number 8. I started to look and say, how did I go from 1 to negative 1? Well, if I added a negative 2, or I multiplied by a negative 1. And then on number 8, the second row, I saw that subtracting a negative 2 would also work. So your rule here would be the function of x is x minus 2, or I will accept x plus the negative 2. All right, let's look at number 9. On number 9, I see that I could have x squared plus 1. Okay, so that was your function rule for number 9. If you square it and add 1, you got that number. All right, number 10. They want us to write the rule for what we see in the reading. So I need you to make sure that you read it, and then we're going to write a rule. All right, so every single day we move 0.3 centimeters. So that means that we don't know how many days, so that's our variable, and it was already 12 inches tall. So when we find out how much we grew in so many days, we would need to also add those 12 centimeters. So you have the function of x would be 0.3x plus 12. Then they want us to estimate the zucchini's height after 3 days. So they're telling us that this time x is equal to 3. So all you have to do is plug in that 3 into our equation and come up with the answer. So you go ahead and pause, and you need to do the work for B. All right, so after plugging it in, you should have 0.3 times 3 plus 12 gives you 0.9 plus 12. So you have 12.9 centimeters tall after 3 days. All right, so now they want to know how many days will the zucchini plant be 13.5 centimeters tall? Well, that is going to be the number of days is unknown. So we have 0.3 x plus the 12. They said the total will be 13.5. So now we have a two-step equation, and now you're going to solve your two-step equation for C and then push play. Okay, so we took 12 from both sides. We have 0.3, make sure you watch that decimal, and it equaled 1.5. 0.5. And please make sure that you use the calculator, because if you tried to say that this was 0.5, you're incorrect. X would have been equal to 5. So it would take 5 days for the zucchini plant to be 13.5 centimeters tall. All right, we're going to go ahead and work on number 11. Okay, so ignore my little spots there. It says the admission to the fairground is $3 per vehicle plus 50 cents per passenger. So they give us already nice and neat written for us to use this rule. Okay, so our rule is $3 plus 50 cents per person. And they use the N, I'm going to use the P. Doesn't matter. Well, it does matter, sorry, because we have our little graph here. So that's N. All right, so they want us to use a table of values. So we have to decide what's N going to be. Well, let's go ahead and start with 0 people. If N was equal to 0, what would our T be? So N times, which would be 0, times the 50 cents would give you 0, and so it would just cost you $3, which no people wouldn't cost, but they're talking about the vehicle. All right, so let's say we have 1 person that goes. Well, 1 times the 50 cents would give us 50 cents plus the 3, so that gives you $3.50. So let's go ahead and say 2. If we had 2 people, 2 times 50 cents would give you $1, and $1 plus 3 would give you 4. I think I'm seeing a pattern here. In my T, there's a pattern, just like we were finding before, because there is a function rule. So if you have a function, you're going to have a pattern. So I can go ahead and say that 3 would be 4.5. Okay? And now they want you to go ahead and graph that. So you're going to take this graph, your X values and your Y values. So your X's would start with 0 to 3, and then your Y values would probably go from 0 up so that you start as a 0, 0. So you're going to make the graph. So your X values are here, and your Y values are here, and you're going to fill in your graph. And then you're also going to answer what would be the admission cost for 6 people. Go ahead and do that and come on back. All right, so your X values, you should have had 0, 1, 2, 3, and from here you would have 0 up to, let's say, maybe if we go up by dollars, so there's 50 cents. I'm going to go up by 50 cents. $1, 2, 3, 4, 5, and 6. And I can't erase once I stop and push pause, which is really silly at this. But so then you should have plotted your points. So for 0 people, it would have been $3. For 1 person, it would have been $3.50. For 2 people, it would have been $4. For 3 people, it would have been $4.50. Okay, and what would the admission cost for 6 people be? So you plugged in 6, and you got 6 times 50 cents would give you 3, and 3 plus 3 would give you $6. All right, this has been lesson 20. For those of you that were on a field trip, you are expected to watch the video and do your lesson prep work so that you are ready to turn that in on Friday. Thanks a lot and have a great day. Be sure that you email me if you have any questions.